Good evening, everyone, and thank you very much for having us. Before I started, I just wanted to acknowledge the joint venture partners who participated in this experiment. So it really is an industry collaboration between lots of different stakeholders to build a particular technology solution that addresses the unique requirements of each of the stakeholders in the biofouling lifecycle. The journey started almost 2 years ago now. And we worked with a couple of companies. Some of those representatives from those companies are on the call, but Clean Subsea, the inventors and operators of the EnviroCart, and also Fran Marine Underwater Services here in Western Australia, who are an underwater asset management company and who provide hull husbandry services. Very, very early on in the piece, and all throughout the development and design of BioPass, we've been working with John Lewis and ESLink to get their guidance and input on how to build this solution in a way that it works for all the different stakeholders. So to introduce BioPass, what we set out to do a couple of years ago, about 18 months ago, was to test whether or not we could use distributed ledger technology or blockchain technology to enable a global implementation of biofouling guidelines on a uniform digital platform to help manage the requirements of all the stakeholders in this particular process. So I'll hand over to John quickly, who can give you a quick overview of the different challenges in the industry that we set out to address.
Thank you, Rowan. In-water inspection, which has become an integral part of biofouling management and the biofouling management guidelines, was something that used to be focused very much on the structural integrity of the hull. So it was very much that class surveyors were required at various intervals to either dry dock the vessel or have divers in the water to make sure that there wasn't any excessive corrosion, that the anti-corrosion coating was still intact. But that viewpoint, as with the advance in coatings, the time intervals for those have actually extended out and out and out. And now that the anti-corrosion coatings are so good, some vessels only have to dock at 90-month intervals. And so anti-fouling paints have been developed, or systems that claim to provide that 90-month interval. So it's very infrequent for that purpose that divers need to do an inspection. But when we come to the IMO Biofouling Guidelines, generally the guidance is you put on an anti-fouling coating system to last for the planned in-service life of that particular vessel. So be it a 2-year docking, well, you make sure that you have a system that'll last 2 years, 3-year docking, 3 years, and of course out to 90 months. Now, from the biofouling management viewpoint, it's a case that some of the regulatory authorities require far more frequent inspections. And one of the recommendations of one state is that a biofouling inspection should, for the first 2 years, be conducted every 12 months. And thereafter every 6 months. So from a period of, heading out to several years and one maybe in-water inspection through the in-service life, they're now requiring to go the other way. And this creates quite a bit of complexity for shipper operators to maintain that schedule, because for an inspection, you need the divers, you need an inspector, you need to take still images and video and then have reports prepared by both the divers and the inspection. And there's a lot of constraints on that through, ship operations and schedules, the time to actually get divers in the water and then what happens with the weather, the clarity, and particularly at the moment, for some of the regulators that require last port of call inspections, of course, with COVID, where the inspectors aren't able to travel to do that work. So the idea of having a simpler system where it's all integrated is something that will both facilitate and make a lot easier the inspection process, but also make it easier for virtually a higher quality and consistent inspection process. And this is where sort of facing these industry challenges is something that we're sort of, if something can help us out, then it will make the whole process a lot better, and ultimately biofouling management a lot better. So I'll now pass back to Rowan to sort of talk about how the system is conceptualized to be able to meet all these requirements.
Thanks, John. So way back when, about 18 months ago, what we set out to look was not just could we use some technology to implement a process, but could we use the technology to implement an entire ecosystem-driven operating model for implementing something like the biofouling guidelines. And the hypothesis at the time was that the blockchain technology allows us to implement more of a decentralized operating model, which can be an effective and potentially very efficient way of implementing the IMO Biofouling Guidelines. And it's also a very ecosystem-driven approach. So all the different stakeholders who participate in the life cycle of this process at all the different stages and all the different stakeholders are all participating in a common information record. So when we look at those three types of operating models for implementing something like biofouling guidelines or any regulations for that matter, we looked at more of a centralized model versus a federated model, and ultimately this decentralized model. The models each have their pros and cons, obviously, but in the decentralized version, it really is a different sort of shift in strategy where you are putting the asset owner or the asset operator more in control of the process. It can accommodate much more variability and much more continuous ongoing improvement. So if different countries choose to interpret the guidelines slightly differently and therefore implement different standards, this way of coming at this problem from a more decentralized perspective doesn't necessarily make that more of a headache for the ship owner or the operator. And it also leaves the accountability of the implementation of those guidelines with the asset owners themselves. So it sort of lifts the standard, lifts the bar for the whole ecosystem, as it were. And then from a blockchain perspective, what we used the blockchain for was to create this common information record which multiple parties contribute to over time as they execute the process. And while that sounds maybe a bit abstract, I think what we're aiming to do today is actually share a demonstration of a workflow with a couple of stakeholders involved, and hopefully have John share a couple of stories that he's come across as he's been using or as we've been testing the system in the field. And ideally that makes this model sort of come to life and much less abstract. So 18 months on from where we started, and lots of sweat and tears and energy from lots of different stakeholders all around the world in lots of different geographies and different types of entities. We have a working prototype. It's kind of moved into field testing, but BioPass basically allows or enables the entire end-to-end inspection and cleaning process. It's designed to accommodate all the different stakeholders in the life cycle or in that end-to-end process, and it's designed to take into consideration this requirement over the life cycle of the asset. So from sliding into the water for the first time all the way through to retiring that asset, this process is designed to live and breathe with that asset as it operates over its lifetime. All of our systems are multi-party environments, and you'll see what that looks like. So it is a digital workflow. It is a multi-party workflow. So different stakeholders participate on this common information record. We will demo some of the sort of more specific use cases that we've developed for this particular challenge. So we can pull, for example, a live video stream into the solution from a diver's helmet or from an ROV or from another device, for example, and then record video and image data directly from that video feed and against the asset certain sections of the ship in the biofouling report. It is a multi-party real-time environment, so it's also, and it's asynchronous. So if there is an issue that occurs, an operator can dial John, for example, into the work, and they can have a discussion about what they're looking at and how to resolve it. If they find an issue with the integrity of the hull, then they can dial in an engineer. If they need to get clearance to clean off an invasive marine species in accordance with the specific procedure, then they can dial in the asset owner and get that permission there on the spot to save money and also to save time in terms of executing that work. And we've also driven in a lot of automation. So automatic delivery of a biofouling report, digital record keeping. So from a logbook perspective, there's no additional work that needs to be done to maintain and update the logbook. It's just sort of captured as a consequence of doing the work. And then also the ability to read AIS data and help operators specifically, or ship owners, make predictions about the potential risk from a biofouling perspective that their vessel may be carrying, so they can make informed decisions as they go from one port or one destination to another as to when to take an intervention to mitigate both the cost of operating but also the risk. In terms of where we are, on the 28th of January this year, we did our first end-to-end field test. We were working in Australia together with Fenn Marine and Clean Subsea, and also with NSM, a company that looks after naval assets. And so the Royal Australian Navy has been very kind to us in terms of allowing us to test the system on some of their vessels. On the 1st of March, we did another successful field test where we broadened the scope. So it was a systems test, but we also started to pull in third parties. And specifically, it was John that helped us test that study. And then later on in the year, we have we'll call it a soft launch, where we will do a field test with all supply chain participants. That's the asset owner, a prime contractor, a series of subcontractors, the regulator, and covering the end-to-end process. So from sourcing and procuring a clean or an intervention, all the way through to paying it and including the successful delivery of it. And in the back half of the year, BioPass, which is it's ready to start being consumed by potential or people who are interested in dealing with this type of challenge, and should be generally available in the back half or back third quarter of this year. So won't pause there because there's no questions, but I'll cut over from the presentation to the actual working software and give a quick overview of it, and then hand back to John, who can share a bit more around his experience with this particular technology and how and where he sees the application, or where he sees it being useful to different stakeholders in the sector. Okay. So welcome to BioPass. You're looking at a working product. So this is our test environment where we've been conducting our field tests. Our systems are all multi-party systems. So I have to log in as different people all the time in order to complete the demos. And in this instance, I've logged in as Kelly from Fenn Marine, who is working on the supply side. So a diving company providing services to an asset owner. And in a separate window, I've actually logged in as Rowan from Rise. And in this context, I'm logged in as myself, but view me as the asset owner, someone who is having an intervention conducted on my asset. So I'll cut across back to the Kelly view. We have a number of different key screens, which we'll demo. This level is the performance view, so where we can look at the entire fleet. So if I'm an asset owner, I have a fleet of vessels and I'm trying to manage biofouling risk for each of them, I can look at the fleet. If I want to drill down into that fleet, I can see all the different work that either has been completed on that asset or is in progress, is being completed on that asset. Where am I now? Keychain bio, it's unique. So if I drill into those fleets, I can see, the other thing I can see is what we call the BioPass port. So the idea around the BioPass port is it gives me access to real-time information taken from AIS data. It pulls port history and it pulls days since the last dry dock, days in high-risk waters, and it makes a prediction as to the level of fouling, fouling that has grown on the bottom of that vessel. Another shout out, I guess, or another collaboration, industry collaboration to produce this functionality. We actually worked with Asynchronous and Safina, and we leveraged a algorithm they built for a product called Port Shield to display that information directly in BioPass to help inform asset owners as to when they should or shouldn't take a particular intervention. If we go onto the work screen shows all work in progress. So it's an end-to-end process, so from order through to fulfillment, where I can both source a job, so I can order an inspection, but I can also complete that inspection. I can resource it, so I can add divers or ROV or in-water hull cleaning equipment. I can deliver that work, so the actual delivery of that work, and then if I push that process through to the end, I can actually pay for that work. So I'll drill down into the delivery component of it for the moment, where we've actually digitalized the work, the operating procedure. And so we built out a fouling procedure in line with the craft risk management standard out of New Zealand, which uses the FR ratings. And we've turned this operating procedure into a digital work procedure, which the operator actually fills in on site using an iPad. And then we can pull live video. So we've got an example of live feed. So we can connect to an ROV. It pulls video into this particular asset, which I can also make a picture-in-picture. And I can continue to execute my work as I access the video. We've tried to make this responsive so that as users are interacting with the procedure, if they move outside a threshold, they get feedback. And also we have a couple of unique features where we can start to tag things in an image. So we could, for example, tag a invasive marine species, save it as such, and then that tag will then appear directly in that image in that biofouling report. Last thing to mention before I hand back to John, this is an AI-enabled platform. So we have a machine learning algorithm running in the background where every time John tags a particular type of species, that machine learning algorithm learns how to identify that species, so that a little while later in the future, you could imagine a circumstance where an asset owner can deploy an ROV over the side of the asset. That ROV can do an underwater inspection. And if they pick up any anomalies, any invasive marine species, they can flag that in advance and potentially notify the port that they're arriving to, so that they can take a proactive intervention before they arrive. I'll pause there because we're about on time and we've covered a lot of ground, and I'll hand back to John. John can tell you some stories of where he sees application for this, and he can also direct me if he wants me to show anything specific that we haven't managed to show in this short time period. And then we're so happy to take questions, and we can move around the asset as we have a dialogue, if that's helpful for everyone on the call. So thank you very much. I'll hand back to John. It was a pleasure to be able to speak to you all, and I look forward to the conversation.
Okay, thank you, Rowan. With the development of this, as a biofouling inspector, in many cases, I much prefer to see a vessel in dry dock. But as we move out to a lot of trading vessels, it's just not feasible to dry dock a vessel every time it visits Australia or New Zealand or some of the other countries that it's involved. So we revert back to the options of doing an in-water survey. Now, when we're working globally, just the logistics of having inspectors, having different divers in different places, and what this provides is somewhere where we've actually trialed that rather than me having to fly to a country and then sit out in a dive boat while the divers are under the water with their helmets, with their CCTV or handheld, I can sit in the comfort of my office with just the same direct involvement with the key person operating the ROV or leading the divers to give the same directions. And not only that, the ROVs that we've tried, the actual imaging is a much better quality than anything we can see from a CCTV. The ability of this is that as we move through the vessel, we're targeting different areas. I don't know whether you can bring up, say, the one for a rudder, just showing what the screen is, that we can then pick on, we pre-identify all the different niche areas. So if we go for the rudder, we can do visually the estimate of fouling cover and intensity, and this is showing the US Navy system of fouling ratings. So we can actually do the calculations here, right, in live time. We can also take screenshots of any particular area we're interested in, and these get loaded into the onto the screen below, and those screenshots and comments that we can feed onto the screen at that same time are then automatically incorporated into the report. So normally, an example being the last Monday doing an in-water survey of a vessel, took most of the day, 2.5 hours of video footage, close to 400 still photographs. And after that, my job is to then select those, often go through the whole footage to get screenshots of relevant areas to put in the report. And you're looking at another, generally 2 days to collate a report for a large vessel, whereas here you've got a point that once you have actually finished, the report has been generated, and not only generated, but it goes into the vessel's, essentially their online biofouling record book. So the whole process is facilitating not only getting that report done in inspection and report done in real time, but to actually have it all as part of the vessel's operational or biofouling management history. So it's then certainly simplifying the whole process. And in trials we've done of this, we haven't actually done a full survey yet, but the trial run we did, and here are examples of the type of photos you can get. We have the ability that we would put up generic types of species, so we can say bryozoan. That little image there isn't actually a tuberculous amphipod, but it's there as an example that we can tag what's there. And at the moment, we have just got sort of the list of the Western Australian species of concern, but we can actually populate that with common biofouling species as well. So when someone looks at the report and where the inspection is done, you get information on where they are. As Rowan just pulled up, you can also identify different types of damage to the coating. So the whole process is something that even a technology dinosaur like me, I don't need to know what's happening in the background, but it means that I can just sit in my office with a big screen and essentially prepare an inspection report of a quality that is as good as anything we can generate from a boat. So
thank you so much for having us.
Thank you, John. Thank you.